So a second method for algebraic division is what I've kind of called comparing coefficients. Not the most unique title, but kind of does what it says on the tin. So I'm not going to use algebraic long division or the bus stop or anything like that. I'm going to try and start almost with my answer and work my way back. Now, a word of warning on these types of questions. They work best when you know already that you've got a factor. So, for instance, say you were sketching a cubic or a quartic, and you already know one of your roots. You could use this method to start to figure out the rest of your roots. So, like I say, really helpful when you've got factors, not so helpful if you're not sure. Luckily, we know how to check whether or not we've got a factor there. We just use the factor theorem. So I'm dividing by 2x minus 1, which means if this is a factor, my root would be x equals a half. Now, you know from class and from videos that if I substitute x equals a half into the function, which is on the numerator of my fraction over here, and it is a root, then my the solution to this kind of substitution will come out as 0. So let's try that. 2 to the power of 2 times a half cubed. It's the half cubed, not 2 times half. Plus 7 a half squared. Minus 14 lots of a half. Add 5. Chuck that in your calculator and you will realise that you do indeed come out with 0. Therefore, 2x minus 1 is a factor. Good. So, I know now that when I divide 2x cubed plus 7x squared minus 14x plus 5 by 2x minus 1, I'm not going to get a remainder. I'm going to have a complete factorisation. Okay, and that's the fact that I'm going to use to help me with this method. So I know that when I divide, I am going to end up with, oh hello, that's quite exciting, there we go, a quadratic. And the reason I know that is if I'm dividing a cubic, highest power of x3, by a linear, highest power of 1, I'm going to be left with an x squared. So I could have some lots of x squared, then some lots of x and some constants or numbers, and that's it. That's all the options I've got. I can't have, x cubes because already my highest power is an x cubed. There's nothing below a number because we know it's going to be a whole factor. It's going to be an actual sort of, you can factorise it properly. Okay, so now what I do is I expand this out. Some people can start to see some of these coefficients immediately, and if you can, that's absolutely great, but I'll take you through the long method and then that way we're all good. So expanding this back out, I'm hoping that it's going to look something like the denominator of my fraction, and then I can start to compare them. So 2x times 8x squared would give me 2ax cubed. 2x times by bx will give me 2bx squared, and 2x times by c is 2cx. Right, all of the terms in the second bracket by the remaining term in the first one will give me minus ax squared minus bx and minus c. Right, I think it's more helpful to have all of your terms together. So that's the only x cubed term. Here I have 2b and minus a x squareds. I've got 2b and minus a x squared, so I've just pulled those together. And then I have 2c take b x's, and then I've got a minus c on the end. Okay, so now comparing this to the numerator of my original fraction, I can see that 2a has to equal 2, because the only x squared term here if it's to match with the top, we'll have to match this one here. Well, both of them contain the x cubed, that's good. So 2 must equal to a, which gives me that a is equal to 1. Then I'm going to jump to the other end. I've only got one constant term here, minus c, and I have one constant term in my original equation, 5. So minus c must equal 5, in which case c is equal to minus 5. Now for the middle terms, I'm going to have to pick one and go with it for a bit. So here, let's look at x squareds. I've got 2b minus a x squareds, 2b minus a lots of x squared, and I have 7 in my original function. So those 2b minus a must equal 7. Now I already know that a is 1, so I could replace that. 2b minus 1 is equal to 7, 2b is equal to 8, and so b is equal to 4. Now what's really nice about this method is that I've got an extra term here that I could use to check. So if I want to check it, I've got 2c minus b, and I think that that equals minus 14. X terms against x terms. I know that c is minus 5, so I've got minus 10. B is 4, so minus 4, and that does indeed equal minus 14, and I know I haven't made any silly errors anywhere. So my factorisation at this stage is 2x minus 1, and my second bracket is x squared, because it's ax and a is 1, plus 4x, and then minus 5. And from that point on, you could finish your factorisation.